So the first part over here is probability or capabilities and the limitations of optimizing the compilers. Then expressing the program performance, that is how to express the program performance, how it deals, and the next one is example of the program. Then eliminating the loop inefficiencies. So what are the various terms that is used in the loop efficiencies or inefficiencies? Then reducing the procedure calls. How to reduce the procedure call, how it deals with, and what are the various drawbacks that is used in receiving the procedure calls. Then eliminating the unneeded memory reference. So eliminate means remove the unneeded memory reference that we cannot need or that we cannot require for this one. Then understanding the modern processor, that is a day-to-day scenario processor that is used, that is known as a modern processor. Then loop unrolling, that means same loop will be going on, going on, going on. Then enhancing the parallelism, then summary of the results for optimizing the combining code, then some limiting factors, what are the various limiting factors that is available over here. Then understanding the memory performance, then life in the real world, that is the performance improvement techniques. Then identifying and eliminating the performance bottlenecks. Then at last there is a summary of this chapter. Just wait. Now let's see what is the role of the compiler that performs algorithm to determine what values are computed at what time in a program and how they are used. They can they can then exploit opportunity to simplify the expressions, to use a single computation in several different spaces or the places, and to reduce the number of times a given computation that must be performed. And most of the compilers that include the GCC that also provides the users with some control over which optimization may apply. And the simplest control is to specify the optimization level. What are the various optimization levels that involve? That includes the GCC, that includes the flag with a set of the optimizations. And when we use program performance, that is also used with the GCC compiler with the level of the with the level of the optimization to demonstrate how different functions in C language can affect the efficiency of the code that is generated by the compiler. That means the main role of the compiler is to compile the language, high-level language into the binary language, and that can also perform some masked or the more complicated version that is compiled with the highest possible optimization levels. Now, this is compiler must be careful to apply one safe optimization to a program. That means whenever we are using the resulting program, that will have a exact same behavior as we have seen with the different versions for all the possible cases that the program may encounter. That may limit up to the guaranteed with the provided by the C language standards. And constraining to the compiler to perform only the safe optimization that also eliminates the possible sources of the undesired runtime behavior. That means that the programmer can make more of an effort to write the programs in such a way that the compiler can transform into the efficient machine level code. And to decide which program transformation are the safe or not, consider the following two procedure. This is the void void twiddle one in pointer XP. Now we are taking the pointer XP so that the memory will be reserved for these pointers. So memory will be reserved for these variables. That means the value will not change, and this will be remains the same. That is the int pointer XP and the int pointer Y. Then XP plus equals to YP. This is again the next pointer. Then pointer XP plus equals to pointer YP. Then twiddle to int XP int YP. XP plus equals to 2 into YP. At first glance, both the procedures seem to have identical behavior and they both add twice the value stored at the location that is designated by the pointer YP to that pointer that is used with this. And on the other hand, the function twiddle is more efficient. Why? Because we are using both the argument that is pointer XP and the pointer YP. And this have only the 3 memory reference. This is read pointer XP, read pointer YP, write pointer XP. Whereas when we use about the twiddle one that requires a 6, that is 2 read of pointer XP, 2 read of pointer YP, and 2 writes of pointer XP. Hence, if the compiler is given procedure twiddle 1 to compile, one may think that it could generate more efficient code based on the computation that is performed by the twiddle 2. Yeah, both are using the same values XP and the YP, but the main part is that Twiddle takes more, Twiddle 1 takes more time, and this will perform or double the value of the XP over here, and this is the double the value of that XP. Now, my question is, yes, my question is here, this is a slash asterisk, then asterisk slash. So what is the use of this slash asterisk asterisk slash? Yes, very good, Joseph. This is a single line command or the multi-line command. Yeah, this is used for the documentation of the program. This result that the value at the XP will be increased by the factor of the 4, and on the other hand, function twiddle will perform the following computation, that is pointer XP plus equals to 2 into XP. So this is yes, this triples the value at XP. Now the result is that the value of the XP will be incremented by the factor of 3, and the compiler will take the value. Compiler will know nothing about how the twiddle will be called, so it must assume that the argument XP and the YP can be equal. That therefore generates a code in the style of the twiddle 2 that can be optimized version of the twiddle 1. And the case where the two pointers may destinate the same memory reference, same memory location, that is also localized with the value, that is also localized with assumption that the different pointer may be aliased. And as with another example, for a program with the pointer variable x and the or the p and the q, consider the following code sequence. This is x equals to 1000, y equals to 3000. This is pointer q equals to y, then pointer p equals to x, then t1 equals to pointer q. This is y, that is a 3000, then 1000, then t1 equals to pointer q. And the value that is computed for the t1, that also depends on whether or not the pointers are using p and q that are alias, and if not, it will equal 3000, but if so, it will equal 1000. That leads to one of the major optimization blockers, aspects of the program that can limit the opportunity for the compiler to generate the code or the optimized code. And if a compiler cannot determine whether or not two pointers may be aliased, it may assume that either pair is possible, limiting the set of the possible optimizations. Now this program is a swap program, that means swapping the values without using third variable. Yes, this program illustrates the way how the memory aliasing can cause unexpected program behavior. This will be used to swap the two values without using third variable, because till now we have discussed that how to use or how to swap the value with the use of the third variable, that is we are using either temp. But here this is not using the third variable temp, but this is the normal with the use of two variable. Now if a question arises, yes, swap the two values. Swap means interchange the two values with three variables. So you normal use call by value and you use the temp as a third variable. But if the mandatory condition is given that without using third variable, you have to choose, you have to swap the two values. That can be done by using the pointer. This is a program where the swapping of done without using the two variables. So this is swap value x at xp with value y at yp. This is void swap in pointer xp in pointer yp. This is pointer xp equals to pointer xp plus pointer yp, then pointer xp minus pointer yp. So first of all, we are taking the addresses of the xp and the yp, we are adding the both the values, then the subtracting both the values, then again we are using as a xp equals to xp minus yp. Now this is a function that will returns the return function. So this is int func2 return 4 into f. Here, this is used for the optimization blocker, that is used for the function calls that will consider the two procedures, that is f function 1 return f and function 2 return 4 into f. So we are either using the for function, that is summing up, or either we are using the multiplication, that is 4 into function. It might seem that at first both compute the same result, that is taken out with the function 2 that calls f only once, so the function f1 or the function 1 call it 4 times. And it is also tempting to generate the code in the style of the function 2, which then gives function 1 as a source. Now consider the code for the f. This is int counter equals to 0, int f return counter plus plus. And this function has a side effect that modified some part of the global program state, changing the number of the times it gets changed for the program behavior. And in particular, a call to the function 1 will return 0, 1, 2, 3, that is 6, whereas a call to the function 2 would return 4 into 0, that is again the 0. So first output gives, or the first one gives the output as a 6, then second one gives the output as a 0. The next one is we are using the how to express the program performance, that is expressed by using the CPE, cycle per element. That is a way to express the program performance, that is a way that can guide us in performing or improving the code. And CPE also, or CPE measurement also help us to determine and understand the loop performance of an iterative program at a detailed level, and it is also appropriate for the program that performs a computative or the repetitive computation that is used within a matrix product. And we are using the gigahertz for the calculations, for the manipulations. This typically involves in the nanosecond gigahertz. That also uses with the set of the elements, whatever set of the elements we are using. For example, the function p7 and p7 both compute the prefix sum of the vector of the length n. And the function p7 computes one element of the result vector for iteration, and then next technique also use or the loop unrolling to compute two elements in the iteration. And whatever the computation that I'm using, that can be characterized by the constant plus, that is determined by the factor proportional to the number of the elements processed. That is used with the least sector set. This is the void P7, this is the void P7. Next is one is a program example. This is one of the example that is given. Now this is one of the example that is given for the program performance. This is creating the abstract class. So to demonstrate how an abstract class can be systematically transformed into the efficient code, you must run the program example that is based on the vector data structure. And what is a vector? That is represented with the two blocks of memory, the header and the data array. So we are using the header, we are using the data array over here. This is the len or the length data. This is 0, 1, 2, len minus 1. This is a vector abstract data type that is represented by the header information plus the array of the estimated length. This is the create abstract data type for the vector. This is the type def struct. So we are using the type definition struct. So we are using the variable as a struct. Then long int length. We are using or we are taking the variable as a length, that is of the integer type, and the long, that means it takes 8 bytes. Then data t, pointer data. So we are using the data t, pointer data. We are taking the pointer data as of the data t type. Then vector or the struct will be closed, and now taking the two variables of the struct. One is a vec rect, one is a pointer vec ptr. So we are using two variables, vec underscore rect, then pointer vec underscore ptr. And the declaration uses the data type data t to designate the data type of the underlying the element and in our evaluation we measure the performance of our code for the integer, that is a C int, single precision floating point, that is a C float, double C double data that takes 8 bytes, int takes 2 bytes, and the float takes 4 bytes. Bytes, not the bytes. This is another example that is given. Now next one is eliminating the loop inefficiency. So if there is an inefficiency that is eliminated by the that is eliminated by the loop, that is the loop inefficiency. So move code to the vec length out of loop. So void combine to vec ptrv data t pointer destination. This is log int t, log int length equals to vec length v, then pointer destination equals to ident. We are taking the for loop, I equals to 0, I is less than length, I plus plus, then data t var, get vec element vi val, then pointer destination equals to pointer destination of eval. We are taking the variable as a, or the value as a val, that is of eval. Yeah, this is a combining of the both the values. This is the converting the string into the lower case, that is lower one, taking the for loop, I equals to 0, I is less than